All right, so in this lesson, we're talking about absolute value equations, okay? You've been doing absolute values since you were little. And what do we do with absolute values? Yeah.
Basically, it's just how far that number is from zero, so it's always like positive.
Nice, okay? Nice. Because usually people will tell me absolute value, you just take away the sign, so you end up with a positive number. But very rarely do I get a student to tell me it's the distance from where?
Zero.
It's the distance from zero, okay? So if I say, okay, absolute value of 4, that's code for the distance between 0 and 4. So if that's what absolute value means, the distance between 0 and blah. So if I told you absolute value of 5, what would you take that as? How much is that? 5, because it's 5 away from 0, right? So this is 5 away from 0, so it's 5. So if I said absolute value of -5, what would you say? 5, because that's also 5 away from 0, okay? So now I say, so this is equal to 5. So when I say -5, that's also 5, because both of these are 5 units away from 0, okay? And if here is 0, then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's all absolute value is. Now if I say, hey, what is the number, okay, x, the absolute value of which is 4. So now this is code for, hey, I've got the secret number x, and the distance from x to 0 is 4. Okay, so distance between 0 and x is 4. If I was walking down the street and if I saw this, just that highlighted part on a billboard, okay, absolute value of x equals 4, I would go, oh, there was a number x and it's 4 units away from 0, right? So now what could x possibly be?
4 or -4.
It could be 4 or -4, because if I'm here at 0, and if I have some number that's 4 units away, there are only 2 things it could be. It could be here, 4, or it could be here, -4. So do you see how you can't just have one answer? You must have 2. Can you have more than 2? If it's just a line, you can't have more than 2. Yes?
So could the number where 4 is right now, could that ever be negative?
Here?
Yeah.
No, because the absolute value is a distance. You're saying that the distance between x and 0 is 4. And that distance can never be can never be negative. So absolute value can never equal a negative number. Okay? That's a very subtle point, but it's a very important point. So if you always think of absolute value as a distance, like if you go to the doctor and they measure your height, they'll never get a negative number for your height. It's the same for absolute value. Okay? Okay. So let's just evaluate first. Evaluate if x is -2. So what we do is, in absolute value, here I have 4 times -2 plus 3 minus 3
Do those lines work
and a
like
half.
parentheses?
Yes. So those lines are like parentheses, and PEMDAS definitely takes into effect. So we go inside the parentheses first, and we do this. Now what do I have here? -8 plus 3. I have -5 inside the absolute values minus 3.5. So what's -5 in absolute values going to give me? 5 minus 3.5. And how much is that? 1.5. Right. Okay. And I can either write 1.5 like that, or what else can I write? 3/2, right. Okay. All right. All right. All right. So 3 minus negative 2 plus 8. So this is negative 2 times absolute value of 5 plus 8. This is negative 2 times 5 plus 8. So what's the answer finally? Negative 2, right? So, okay. So let's solve absolute value equations. All right, so what this says here is I've got something, okay? Forget that it's x minus 5. Suppose it's just something. And the distance of this something is 3 from 0. So where is that something? If this is 0, it could either be at 3 or it could be at negative 3. So now I say, okay, that something is either 3 or negative 3. I'll get you in a second. So I say x minus 5 can either be at negative 3 or x minus 5 can be at positive 3. So whenever you have absolute value equations, you're always going to end up with two equations.
Why in the first two that we did we only end up with one?
Because those were not equations. This is now an equation for the first time, okay? All right, so now I have two mini equations that I solve completely independently. So what's key is you take what's inside the absolute value, you set one equal to the negative and one equal to the positive. Okay, so now I just add 5 to these. So this is x equals 2. And here when I add 5, I get that x is equal to 8. Now on a test or quiz or in your homework, you give me both of these as a final answer. Okay? You can, but just make sure that there are two answers. Make sure that there is no question that you got two answers.
So like when the equation comes up just like this, the answer is always you're gonna put a negative and a positive to the.
Yes. Yes. Okay. No, positive because I add 5 to both sides. So it's 5 plus 3, 8. Okay? So you're always going to get two answers. And they don't have to be positive and they don't have to be negative. They could just be whatever. All right, let's do a couple more. All right, so solve each equation. So again, I have x minus x plus 3. I have something in the absolute value. And the distance of that something is 6 units from the origin. So it could either be at 6 or it could be at negative 6. So I say x plus 3 is equal to negative 6. X plus 3 is equal to positive 6. Now, I subtract 3 from both sides. I get that x equals negative 9. I subtract 3 from both sides. I get that x is equal to 3. So here we go. I have two answers. Okay? Yes, positive 2. They were both positive because I added 5 to both. Okay, so here, okay, okay. All right, let's do this one. So this something in the absolute value is 4 away from the origin. So if it's 4 away from the origin, it could either be at 4 or it could be at negative 4. Okay? So I say x minus 7 is negative 4. X minus 7 is positive 4. And go slow. Write down your steps. Okay? So here I add 7 and I add 7. So I get x equals 3. I add 7 and I add 7. So x is 11, and I have two answers. Okay?
So what are you doing to memorize? Point to the right.
Right, I've just put it there so we have a visual. You don't have to, I just put it there so we have a visual of what's happening. Okay, so look at this one. What you want to do first in this is isolate the absolute value. That's what we always do first. Isolate the absolute value. So to isolate this one, I have to divide both sides by -2. Now I get that the absolute value of 3a is equal to -3. Well, what is this telling me? This is telling me that there is something, the distance of which from 0 is -3. But can a distance ever be a negative number? No. So this is a no solution because a distance can never be negative. Okay?
Anytime we see that,
No solution. Okay, so anytime an absolute value is equal to a negative number, it's no solution. Absolute value can't equal a negative number. Okay, because distance cannot be negative. Questions? Yes. As long as the negatives cancel and your absolute value then equals a positive number, you're good to go. Okay? Yes.
in the top one, we got negative. I got -9.
Yeah, so did I.
So does that mean?
It's totally fine. Your answer can be whatever it wants it to be, but you can never have something like this where you have absolute value and then an equal sign and then a negative number. Okay?
That's x equals negative, not the absolute value. Oh, right.
That's the stuff inside, right? Okay, so look at this one. Let's talk about extraneous solutions. We're gonna solve it. Do you have your notes back? Is it at home? It's in your locker. Okay. So take a look at this one. First thing we're gonna do is isolate the absolute value. Okay? So here's what we're going to do. We're going to add x to both sides. So I have 2x plus 1 is equal to 4x minus 4. All right? Now, I need to get rid of that 2. How would I do that? Divide by 2, and here I divide everything by 2. It's like communism. Everybody has to get equal treatment, right? X plus 1 equals 2x minus 2. Okay? Now, where is it a 3? I'm dividing 4x by 2. I added x here, so it became a 4. So now I have something. The distance from the origin is 2x minus 2. Okay? Now don't let that throw you off. You still do the same. You say, okay, I'm going to get two equations. 1, x plus 1 is equal to negative of whatever was on that side, 2x minus 2. And then x plus 1 is equal to the positive of whatever was on that side. Yeah. Yeah. So here, let's simplify a bit. X plus 1 is equal to 2x plus 2. Okay? We distribute the negative, so it becomes negative 2 here. Now, I add negative 2x. I add 2x. And I add 2x. So I get 3x plus 1 is equal to 2. What do I do to the 1? Right? So 3x is equal to 1. So what's x equal to? X is 1/3. Okay? Now, what happens here? Subtract 2x.
What happened to 2?
I subtracted a 1. So here I have negative x plus 1 is equal to negative 2. Subtract 1, subtract 1. Negative x is equal to negative 3. X is equal to 3. Now, sometimes when you've got cases like this, where you've got an absolute value, and you've got an x inside the absolute value, and you've got an x outside the absolute value, when you get your two answers, you have to plug them in to check that they both work. Okay? So let's check. So let's check the first one, x equals a third. You go back to the original equation. 2 times x plus 1 in absolute value minus x is equal to 3x minus 4. Okay? And we want to check that that's going to work out. So let's see. 2 times 1/3 plus 1 minus 1/3. Is this equal to 3 times 1/3 minus 4? Okay? Let's see if it's going to work. This is 2 times, what does this give you? 1/3 plus 1. 1 and 1/3, which in fractions, in improper fraction is 4/3. Minus 1/3. Is this equal to, what do I get here? What's 1 minus 4? Negative 3. Right? So now, what's 2 and 4/3? 8/3 minus 1/3. How much is that? Right, this is 7/3. Is that equal to negative 3? No, so that doesn't work. This answer, all that, we did it for nothing. It doesn't even work. Okay? 4/3. Yeah. Okay, so now let's check the other one. Yes. Which 4? This 4? This one? Okay, so this 3 and 1/3. 3 times a third is 1. Minus 4 is negative 3. Okay? All right, so okay, give me 1 second. Go ahead and check the other one. Plus 3 is a solution to this. This is my original equation. I plug in x equals 3. So let's plug in x equals 3. 2 times 3 plus 1 minus 3. Now I'm checking, is this equal to 3 times 3 minus 4? Okay? So here, 2 times 4 minus 3. Is this equal to, what's 3 times 3? 9 minus 4. Here I get 8 minus 3, 5. It does equal 5. Yes, so x equals 3 is the only solution. That means that other one that didn't work, we call it an extraneous solution. Uh-huh. So on the answer space, like on the test, on the answer space for this problem, you would write x equals 3. If you wrote x equals 3 and 1/3, you do not get full credit. I do take points off. Okay? All right. On the homework, all of the ones that have an x inside and outside the absolute value are ones that you must check for extraneous solutions. All right? So this is going to be due Wednesday. And your quiz is also on Wednesday. All right, so the first one says to evaluate, and it's given you a few points. So we plug them in, and A is 5, B is negative 1.2, and C is 2. All right, so what do we get here? It's 5 squared times negative 1.2 squared minus 2 squared all over the square root of 5 negative 1.2 plus 2. Okay? So 25 times 1.2 squared is 36 minus 4 over negative 6 plus 2. So we get 32 over the square root of, what is that? That, I guess I didn't check this clearly. Yeah, you know what? Let's add a negative in here. I'm going to change the problem and add a negative in there. But I'll make that positive. Yeah. We can do that. So it's negative AB. So it'll be an 8.
We're not actually changing like the variable.
No. So 32 divided by root 8 is 11.3. Okay. So here we have 25 times negative 1.2 squared. And I plugged it in the calculator, yeah. So 1.2 squared is 1.44 times 25. So try it out on the calculator. Okay, so look at this one. For these, you need to be careful. You have root 9 over 2. How much is that really? That's 3 over 2. So what type of number is that? It's real. What else is it? Rational. And you don't have to write real. You can. You don't have to. What about pi? Is pi a rational? It's irrational. It's sort of, it's, okay. Yeah, they're all real. We can skip that one. How about 35? 35. It's all of them, right? So it's rational, integer, whole, natural. Okay, let's solve this one. 6b minus 5 equals this. So 6b minus 5 equals 3b plus 6. Subtract 3b. So 3b is equal to 11. b is 11 over 3. And if it doesn't specify that you have to put it in a decimal, you can just leave it as 11 over 3. Okay. It's 11 over 3. No, this one just says solve. So for rational and so on, that was for 2 to 4 only. Okay. On the quiz, like I'll have specified which numbers each one belongs to. Okay. I added 5 to both sides.
Oh, okay.
Yeah.
Quick question. What's the question on the homework? What if equal to 0? 8 in the
This one is just simplifying, and we have fractions, but we're not going to let that scare us. So it's 5 over 2 times A minus 5 over 2 times 2B plus, now we distribute the 2/3, 2 over 3 times 6A plus 2 over 3 times B. Okay, so here I have 5 over 2A. Can't do much about that. Minus, these 2's cancel, so I got 5B, plus the 3 and the 6 gives me a 2, so how many A there? 4A, plus 2 over 3B. Now, I'm going to combine like terms. 5 over 2A plus 4A, right? So let's go here on our scratch paper. 5 over 2A plus 4A. Common denominator is 2. So here I get 5A plus, if this is over 1, then I get 8A. So that's 13A over 2.
Wait, why is it 8A?
Because 1 goes into 2 twice. 2
Oh,
times
right.
4. Okay, now, what about the B's? Negative 5B plus 2/3 B. Now, let me show you the shortcut way of doing it as well. It's going to have a common denominator of whatever this is. When you have a whole number and you're adding or subtracting to a fraction, here's what you do. You do a loop. 3 times negative 5 is what? Negative 15. Plus 2 is negative 13b. That's the shortcut.
So you do the
Okay?
numerator added to the number and then the denominator.
Yeah, you do a loop. Times, plus, times, plus. So now you're done because you can't do much more with that. So it's 3 over 2a minus 13 over 3b. Okay? Solving this for m. Okay? Solving this for m now. This is over 1. Okay? We cross multiply. P times m times n equals r plus 5. Now, I need to solve for m. So I divide by p and n, and I divide by p and n. So I get that m is equal to r plus 5 over pn. Okay, and all right. Yeah. Are you sure? Now, okay, so here we have to solve and note the property at each step. Okay. I'm going to put this on haiku as well. So if you want to, so for this one, number 8, I'm going to distribute and I'm going to distribute. So I'm going to get negative 3n plus 9 equals, plus 6n minus 4 equals 14. So what did I do here? Distribute. So this was the distributive property. Now, right, now we're going to add negative 3n plus 6n, and that's going to give us 3n. And we're going to add the 9 and the negative 4, and that's going to give us a 5 equals 14. What did I do here? What? No. Substitution. So addition and subtraction are only for when you add the same number to both sides. Now, what am I going to do here? Minus 5, so I get 3n equals what? 9. What have I done? Right, addition, subtraction. Either. Now what am I going to do? Divide by 3, so n is equal to 3. Division, multiplication. Okay.